Hi everybody. Just wanted to give you a brief rundown on how the transistor here works. On this transistor we see an NPN transistor. That is negative, positive, negative transistor. It is divided up into three basic parts. Here C is the collector, B is the base, and E is the emitter. The specimen shown here is a bipolar junction transistor, which is a current-controlled current source. What we're using is a 470 ohm resistor and a 5 volt source. Here we have a 640 ohm resistor and a 3.6 volt source. And now what we're going to do is we're going to switch the base from high to low, and we're going to show how the transistor can be used as a switch. Here we see a low output. Watch what happens when we switch this to low. It goes high. All right, what's happening here is that the current is no longer being drawn from the transistor and brought to ground. It has turned off the switch, and thus the current can now flow out through the high instead of through the transistor. Watch again, and you can see the transistor is being used here as an inverter. This resistor and this transistor gives us a logic system which is called resistor-transistor logic. Resistor-transistor logic is an old style of creating digital logic, and it was a common mechanism for implementing various kinds of digital systems. The most educational part about this circuit right here is that it gives you a basic introduction to the operation of the transistor. Let's try and do another element from the logic family. We're going to do a transistor-transistor logic inverter. And now we can see there's a fundamental difference between this and the resistor-transistor logic. Here we have two transistors. Again, we have a collector, a base, and an emitter. And over here we have a collector and a base and an emitter. And these are NPN transistors, bipolar junction transistors, and we could see the logic low over in here. Let's see if we can invert that. And sure enough, we can. By directing the voltage away from this leg of the circuit, we essentially allow it to draw more current in this direction than it does through that transistor. So this transistor is gating this transistor on and off. And that is the essence of transistor-transistor logic. Let's try another one. We're going to do a logic family based on CMOS. Here's a CMOS inverter. CMOS stands for complementary metal oxide semiconductor. CMOS works differently from BJTs. Bipolar junction transistors are current-controlled current sources, but metal oxide semiconductor field effect transistors have a different schematic representation because they have a drain, a gate, and a source. And these are voltage variable resistors. They're not current-controlled current sources. So these allow you to actually switch based on voltage, not current. And it allows you to do a very similar thing. But notice, because we're dealing with voltages instead of current, there aren't any resistors here at all. And so that those resistors were current limiting current sources. But here we're just dealing with switching voltage. And you can see it's a simpler circuit, but it requires the MOSFET to be fabricated. So thought you might like the little demo. You don't have to know much about MOSFETs or BJTs other than MOSFETs are voltage variable resistors, and BJTs are bipolar junction transistors that are current-controlled current sources. Thank you.